How's it going, everyone? Welcome back. Today we're going to be working on the power supply some more uh, and getting more into the digital side of it. Um, a couple of things to go over. You may have noticed the background here. I got a green screen, so hopefully that'll be cool. I'm planning on rearranging the layout of the stream here soon when I get a chance, and maybe I can make something a little better and a little easier to see for everybody. But yeah, so that's a thing. So hopefully that'll help with the weird colors in the background too and everything, now that I can just put whatever I want to back there. And I felt like I had something else to say, but I can't remember what it is right now, so I'm not going to worry about it. Alright, let's get to work. Alright, we probably need to change our current goal, because we've done the high-level design. Supply... Oops. We probably need to do the schematic. There we go. There. Let's try that. Alright, I'm going to turn the music back on. And there we go. Oh, hold on 2 seconds. I will be right back. I had something else I gotta take care of real quick. I'll be back in like 30 seconds. Apologies for that. Left a door open, thought you all would be able to hear some background noise, so got that fixed. Alright, let's get to work. So we made the, man, I feel like this music is really loud, but I think it's just my volume. We made this AC to DC converter last time, and we got this bridge rectifier to convert it to DC and these two super caps, effectively super caps, to help smooth out the power, and this transformer to step down the voltage. So I think we're all good to go there. Next thing is we need to create the, I guess, the adjustable DC voltage side. So we have our 28 volt DC coming out of this. Now we need to be able to adjust it. So I think we probably need another schematic sheet. What should we call this? Just DC power, I guess, because the other one's called AC power. All right. I think before, too, I did pick out a regulator. But I don't know if I saved that anywhere. Oh, I did. Okay, cool. Here we go. 1.5 amp adjustable. So input is from 8 to 35, output is from 1 to 35. Oh, that's quite a lot, actually. Can it adjust up? Because that'd be really cool if it could. I guess we need to look at the data sheet and figure out. There's a single channel step down switching regulator indicator with the P channel MOSFET circuitry eliminates need for external compensation and consisting only of a diode, a coil, and a ceramic capacitor, reducing the board size significantly. Internal resistors, soft start time 4 milliseconds, built-in overcurrent and thermal shutdown, protection circuits, on-off control via standby pin. There's obviously a few things we will need, but hopefully we can get the values for all of that. Okay. Out, ground, output voltage feedback, on, off. One to 0.8 times C minus I out times R on. Oh, interesting. Okay, so it gives the formula here. Man, I really hope we can get 24 volts out of this. I didn't notice that calculator before, or that equation before, so let's just run a quick calculation based off that. So our incoming voltage is 28. If we multiply that by 0.8, I think that already puts us lower than, yeah. We may not be able to get 28 volt or 24 volts out of it. So it's 0.8 times VCC minus I out. So in that case, of 1 amp times R on. What's R on? Oops. R on. Output on resistance, got it. Okay. Where the max is 1.5. Oh wait, which one are we using? We're using the 9873, so yeah, 1.5. Okay. So 28 minus, we said 1 amp times so 28 minus 1.5 is what that end result would be. 28 minus 1.5 is 26.5 times 0.8 is 21.2. Well, that's a shame. This is a really good, it seems like a really good regulator. I was hoping to get 24 out of it though, but I guess this isn't the end of the world. Maybe we can modify later. Yeah, we can modify later. We'll just try and get as much as we can out of it, see what it can do. But I'm not that worried. All right. So knowing that, what's next? All right. I need to, here, I have our diagram. So we've done these top four things: this AC input, the transformer, full wave rectifier, that's the bridge rectifier, and the really big capacitor. We did two of those actually. So now we need the four switching regulators, the fuses, the relays, the mechanical switch, and then the output. And then status LEDs. Yeah, okay. So let's just start with that output then. So our four switching regulators. Well, we know which one we're going to use, so I suspect we'll have to make it because it's not going to be a pre-made part here. Yep. Create new component. All right, and then let's see what's the best way to do this. Let's do a new symbol and start with a rectangle. All right, and then we need one of these, one here, and one down here. All right, we'll flip this around. Oh wait, no, this is actually right. It's the other side that's wrong. Here, I'm actually gonna, let's put it up here. All right, is this 190? Nope, 270. If you get a chance, let me know how your Tuesday's going. Hopefully it's going well for everyone. You know, nothing we're going to be doing with any of these control lines that we're going to have to use. So we're going to have a bunch of control lines from the micro, right, to control different things. Nothing that we're going to be doing is going to be particularly difficult or weird. It's all going to be just basic I/O, really. I think SPI is the only thing that's not. There's going to be some ADC lines and then an SPI, and the rest is just basic slow switching I/O. So, yeah, it's not going to be that hard, but there's going to be a bit of it, like a fair amount. So we're going to need to get something with a reasonable amount of pins. Okay, I'm gonna turn the, is it the name? I think it's the name. No, it's the designator. Oh, wait. Yeah, I usually turn the name off. All right. So that looks good. All right, and then is there anything else we need here? I think we're good. Sorry, I'm all over the place today. It's just a lot going on. All right, we need a footprint for this. Let me see if I can find it. Well, somewhere here. I guess this kind of tells us. All right, let's see. They don't actually have an actual footprint in this data sheet, so yeah. So we'll just have to do the math on this to figure it out. All right, I'm gonna use this picture right here. And let's do this. All right, so pad needs to be big enough for 0.92 millimeters. I'm assuming this is millimeters. Yep. Oh, 0.82 plus or minus 0.1, so 0.92 at its thickest point. So we'll just say 1.1, I guess, just to be safe. Oh, let's use metric. All right, 1.1. And I imagine these all have to be sizable as well. How far apart are these? 1.778. We could probably get away with 1.75. Maybe that should be 1.05. I don't know, that makes a whole lot of difference, but it might. Okay. Oh, excuse me. Long day. All right, so this one goes in the center, and we need to drop it down. 4.12 minus 2.85. So 4.12 minus 2.85, 1.27. And this is going to be, well, it's pin 3, but I don't remember which one that is. I'm assuming probably ground, but I'll leave that for the moment. All right. Whew. All right, so how high up do these? So we know that all these line up. So the Y on this is going to be, hold on, let me just unlock them all. I apologize if I'm not super entertaining tonight or whatnot. It's been a long day. Whoops. All right. And the distance between each one is 1.778. So we need to go twice that distance for these two pins that are that far apart. So this one's negative 3.556. Thought I heard a dog barking. And this one's positive 3.556. All right, and these ones, 2.85 minus 1.58. Is, yep, positive 1.27. And then negative 1.678 and positive 1.678. All right, so that's our layout right there. So go ahead and lock all these in place. And you know, honestly, I'm just going to name them according to their numbers. I'll go change the designators in the symbol drawing. So that's 4, 3, 2, 1. All right, now we need to draw out the, probably need to draw out where this thing is going. Whoops. And I'm actually going to put some lines in here too. And we'll see what that gets us. Okay, so now So 4.5 minus 2.85. $1.65. So the y on this needs to be negative 1.65. Oops. Okay. And then this as well needs to go down to negative 1.65. And then on the positive side, we need to go up to 2.85. Oops. Okay, and then the width is 10. So 5 is where we want to be. Yep, that one's good. That one's good as well. Okay, so this is the outline more accurately of where that where the part's going to be. Let's make this 2.25 and negative 0.75. Whoops. Other direction. 0.25. There we go. This one will be 1.25, and this will be 2.25. That way we don't have our silk running over our pads. Okay. I think that's everything. Now I just need a model for it, and I don't know if they'll have one here. At least not the right one, so. Yep. They do not. So we might have to make our own. All right, well, the square of this with this dimensions is going to be part of it, so we can start with that. I wish it was easier to adjust these things, but it's not. Sorry, just a second. All right, I think that'll be okay for now. This is the base. Height is 8 and offset is 1. Okay. Go to the 3D view. We're just going to make a very rudimentary model. Here we go. All right, and then the heat sink. And this is going to stand off 9. Well, actually, I guess it'll just stand off 1. Let's have 2 in the same place, and then extrude 15.2. Okay. So now if I go to 3D view, here it is. Oops. There we go. I have no idea how to do this. There we go. See? That matches this right here perfectly. All right. That should be good. So save that. We'll go back to our symbol. We're going to change these to have the actual pin numbers as the designators. So VCC is 1. And I guess we'll turn the names back on since we're going to have to do this. All right. Out is number 2. I have a visitor. All right, ground is number 3. Standby is 5. Inverter is 4. I mean, someone left, so. All right, there we go. That one's good. So now, all of this should be okay. And we should be able to save it to the server. No errors. Looks like it. Cool. All right. So now we can place this part. Let's go ahead and save all our documents and get this backed up. Did something freeze? Well, it looks like it's not my internet, but something's not working here. It froze. Dang it. All right, well, while we wait for that. So those are our 4 switching regulators right there. We're going to need a lot of components to kind of put around those. Hopefully for those we can find stuff that already exists in Circuit Maker. And then for fuses, I wish I could do some sort of little like mounted thing so that I didn't have to worry about blowing a fuse, but yeah. It'd probably just be more expensive. I mean, those aren't like a fuse holder. I don't know if a fuse holder is that expensive, but here we go. I suppose we can look that up real quick though. Well, let's not use that. We're gonna need that. We'll use this. Problem is they're just big too, and we're already doing a ton of giant components on this board. I'm afraid of making it too big. they have any surface mount options? Yeah, something like this is what I was thinking of. So you could easily just snap it in and out. Looks like it's not that expensive. 70 cents. So that's an option if we're super worried. Actually, in my case, because of what my soldering tools are, that actually might be a good idea because I don't really have a way to pull off a component if I mess it up. All right, we'll come back to that. Looks like this is done. All right. This one. We only need 4 of them. Four. We might have to break this up if it becomes too much for one schematic. Oh, it didn't auto-name them. Dang it. Have I already used any U's? U1? No, it doesn't look like it. U2. U3. U4. Honestly, we could probably put the names above them. Give us a little room to work with here. Okay. So we can turn the regulators on and off with a standby. And then we got to figure out, I guess we just need to go through and figure out all of the components that we need to add to this. Looks like 4 capacitors, a diode, an inductor, and 2 resistors. 5 capacitors, maybe. All right. Well, first things first. We do know what's coming into this thing. So on each one of them, all right, and then what is it? It's DC 28 volts. My favorite thing too is we're going to put those super caps on these wires. On these exact same wires, and then we're going to put really small caps near the regulators on each of these wires. So it's going to be just like all just like adding together, right? All right, so we probably need to figure out like what all these values need to be and everything. So I'm looking at this schematic here. We have C2, Cn, C1, C3. So if we look through this, well, that doesn't really tell us anything, does it? I know there's an example schematic here somewhere. Here we go. 100 microfarads, and then 4.7 microfarads. C3 to C4. They've also named these things differently. That's 680 microfarad, that's can cap. Microhenry. Output is on when standby is high. Interesting stuff. Place capacitors between VCC and ground, and the Schottky diode as close as possible to the IC to reduce noise and maximize efficiency. Connect resistors between invert and ground, and the output capacitor filter at the same ground potential in order to stabilize the output voltage. Because ringing your waveform crack. Here's how to calculate the inductor value. The output voltage, the coil ripple current value. The oscillation is the oscillation frequency. Interesting. Okay. The resistors determine the output voltage. 1 volt times 1 plus R1 divided by R2. Select resistors less than 10K. Otherwise, they won't have enough current flowing through them. Oh, they give recommended components. Well, that's useful. Which one are we looking at? I keep forgetting. It's the 7.3. I can't remember if it's the 7.3 or 7.4. Of course, they recommend their own diode. They use the same components for both. RCR1616. Let's see what this looks like. Well, there's none in stock, so they must be discontinued. Or they're a non-stock item. Interesting. It's a big inductor though. All right, but we can go for something similar. All right. Ugh. Excuse me. Last thing, I want to learn how the standby works. I need to know its threshold. Rating 36 volts. Okay. Standby pin. So from 2 volts to 2, that's on. 0.3 or below is off. Interesting. We're probably going to want a really strong pull down on that just to make sure we get that, because that 0.3 is kind of low. This is designed to have something very low voltage controlling it. That's kind of cool. Did you get a green screen? Yes, I did get a green screen. Thank you for noticing. Actually, since we're asking about it, if I turn the filter off, there it is. That's the green screen. And then I can turn it back on. Oh, dude, I'm all for it. Like, I desperately need to find a shirt the same color as this thing. And something to put over the chair, too. That would be awesome. It's 5 microamps circuit current. All right. Well, I think we won't have any. So obviously, with this 2 volts up to VCC, like we're not going to have any issues. We can just go ahead and we don't have to do any conversion between the level shifting between whatever our controller is and this device. So that's good. So for all of these standby pins, I'm just gonna have to name them some data line. Channel 1 standby. That seems like a good name for it. Oops. All right. Oh, I named that one wrong. Channel $sign standby. Channel 4. All right, and then ground. I might have to move all of this over some. And probably squeeze it together some. Yeah, let's do that. 1K. Drop that there. All right. Then probably just slide all this over. Stay there. Just trying to get enough room to put all the stuff on the outside here. Okay. So now, we know that, we know our, oh, we need a pull down resistor, I forgot about that. That's probably first and foremost. What's the output of a pin usually? It's like, at best, like 10 milliamps is probably what we can assume. So it'd be at 3.3 volts. So the smallest resistor we can have is 330 ohms. That'll do that'll cause 10 milliamps of current to flow. Obviously we should go higher than that, so probably like 1K is fine. Let's see if we can search something. 1K resistor 0805. That's a 10K. Oh, it is a 1K. It just has a 10K picture on it for some reason. Okay. Alright, so what's this part number? A6AR W102V. They do have some in stock. Wow, they're expensive too. Ugh, I'll just find my own. This is not a part that should be expensive. It should be really, really cheap. All right, here, I'll pull this up here so you all can help out. All right, we need exactly 1K ohms. All right, and then we need this in an 0805. All right, there's only 149 of them, so let's do stuff you can get in cut tape. All right, And why is this one $23? Oh, they are expensive. Am I just missing something? Don't want anything. Oh, these are probably like high powered or something like that. Let's go on the cheap end. Yeah, a lot of 10-cent options. Let's just do 5%. Make it easier. Here we go. This one right here. Maybe this one will be in here. Hey, it is. All right. Let's place these. 2, 3, 4. All right. Turn off the name and we'll rotate. It's going to take me all night just to get the components just for this. We'll still have to find fuses and then get switches and all kinds of fun stuff. Oh, sorry. I wanted to mess around with some solid state relays, so I think I'm going to use those for electronically switching them on and off. Did I put that in our drawing? Uses relays. I did. Okay, so for these relays, I'm going to use solid state relays. I'm wondering if this shouldn't have a capacitor next to it too. Move this out some in case I do that later. Just to stabilize it, especially with all of the oscillation that's going to be going on all over this board. May not be a bad idea. All right. All right, that's connected. So that'll keep it off unless it's purposely being driven high. All right, next we need the capacitors on VCC. Really everything. So this is their example. I don't see much reason to deviate from this. Yeah, not really. All right, let me look up this part number 2. Just see if this is a common part in stock. They've recommended something that's obsolete. That's okay though. I can use this to find something. Use the specs that this has. How do you spell Schottky again? All right, I'm just going to use the component values that they have, but I'm going to change the resistors, obviously, because I need different voltages. So what that'll look like is probably a small resistor on the high end, and then on the lower end, a rheostat, an SPI controlled rheostat, so that I can set that resistance and change it on the fly. Oh, I totally forgot about the display that was going to be on this, that I'm going to put on this thing. Well, that should be fun. All right. So looking at this, I want a 40 volts reverse, 3 amps forward voltage, or average rectified, sorry. That's quite a lot. All right, let's see what this gets us. Yeah, see, like some of these are huge. Not too expensive though. That's good. All right. Any other major voltage forward? There's a through hole option? That would be nice. So probably 550 or less. Man, something like this would be really easy to place. I might just do that. It's cheap. Through hole is very easy to use. Yeah. That's definitely going to be an option. Though something like this would typically take up less space. Yeah, I might just do that actually. All right, let's look at them based on price. Ugh, I need a cut tape or bag, I think. Is ROM even in this list? No, they stopped making something that's even fits the specs. Oh, oh, excuse me. All right, I guess I'm just going to look through at this point with what we got here and see if there's anything. Uh, well, let me see where this is going first. Again, remind myself. And then see if there's anything that is just already made. This goes between ground and out. Okay. Well, that's easy enough. So let's see if we can just look through these part numbers and find one that already exists. I'm willing to bet that it's going to be kind of hard. And there's a good chance that none of them do. This is a weird one. It has 3 pins. Oh, no picture. I'm just working my way up through the more and more expensive items until I find one that's already has a package made for it. If I can't find one, we'll just have to make one. Oh, this one does. Look at that. All right, we'll use this one. 2, 3, 4. I don't totally know what this diode is for, too. I should look into that, because I'm sure that'd be really interesting. Wrong way. All right, let's see. I'm hoping next time, on the next stream, or the one, maybe next week. Let's run this out to here for now. We'll be going back to the NeoPixel sign and assembling that circuit board. I still don't have a cheap way of 3D printing, so that project might just have to get put on hold. I've got to figure out a better solution to that, because the mechanical stuff is like, it's just hard to find a solution for. It's so expensive compared to the component side. So hopefully one day I'll get my own 3D printer. All right, looks like the inductor is the next thing, actually, right after on the output. So maybe that's the next thing we should find. They use 100 microhenries, and I know the part that they selected was no longer in stock, so Okay. So let's find something similar. Inductor. All right, in stock, active. Inductance, we want 100 microhenries. Which is quite large. I really hope we can find a cheap one. All right, we want a ferrite core. I don't know necessarily that we definitely need a ferrite core, but this has one, so. All right, I guess it's shielded. See if we can find a through hole part. That might be a little easier to place. 3 remaining. All right, well that's pretty reasonably priced. Current rating 740 milliamps though. That part's not good. We probably need to. All right, so we will get rid of the mounting type. We're just going to go with the surface mount. Current rating. I don't know, 1.5 or bigger. That gets us down to 201. Oh, that didn't work at all. Okay, 35 remaining if we do that. Let's go based off lowest price and what looks like we could actually like solder it. I think it's had something about the resistance on this too. Okay, actually it doesn't say anything about the resistance, just that watch the current. Okay. So I think we're mostly okay then. All right. I guess we could go through and just find one that already has a part made, if possible. Oh, this one does. Wow. Okay. It might be a little tricky to solder, but I think we could do it. All right, let's do it. Two, three, four. How's it going, Beth? All right, I'm gonna drop that there and move this over. Whoops. Come on. There we go. All right, I think that's connected. Yes. Actually, I'm just gonna go through and delete these and reconnect them. Good. Glad to know it's going well. Okay. It's your hump day? Yeah, 2 more to go. I know that feeling. Alright, so I got the... Sorry, I lost train of thought there. I got the inductors. The inductor on. Now we need... Let's see, can capacitor... Okay. Sorry, I'm looking at this diagram here. This is kind of a method for laying out the whole thing. I guess we should try and get these capacitors first. Alright, let's see if we can find something. 4.7 microfarad capacitor 0805. A lot of options here. That's right, it's really hard. I can't copy and paste that, which is really aggravating. Copy? In stock at DigiKey, it's 80 cents. I don't wonder if they just automatically push the most expensive things they can find all the time. This search option is like great and all, but there are some things about it that need help. Alright, I'm just going to find my own. Again. Give me a ceramic one. In stock, active capacitance. Scroll. Hold on. .7 microfarads. Now let's find an 0805. And we need something cut tape. There's probably one of the ones we were just looking at. So the reason for the cut tape is typically you can buy them individually. .10 volts. It's going to be higher voltage than that. Dang it. That actually might make this hard for us. We probably need 35. So yeah, they are more expensive if you do that. let's try this one. Go from this list, see what's in stock. That one's in stock. Works for me. And it's only 20 cents each. So not horrible. All right. Probably getting close to being done for tonight. All right, and then we need to connect it to ground. Should be this wire here. All right. So that should be good to go. All right, what's next? 100 microfarad. This will need an electrolytic capacitor. Okay. And we need 100 microfarads. In stock, active. Sorry, I'll bring this up so y'all can see it. All right, this gives us quite a lot of options. Probably just go for 35 volts rated. And then see if we can find through hole. I just prefer that. All right. Well, I guess I have to find one, huh? All right. The cheapest one has a part made for it. 20% tolerance. That's probably fine. All right, we're just going to use these. They're through-hole components, so if we change them later, it's really easy just to stick another part in that same spot. It needs to go the other way. All right, let's see here. We're getting there. We're definitely getting there. I should start putting a PCB dock together just to see all this stuff in it. Because there's definitely a lot going on. All right. Getting close. We have the diode that... So we need the output capacitor and then the capacitor for the voltage divider. So the output capacitor is the same thing we just had, except it needs to be a 680 microfarad. All right, and then as far as the voltage rated, it needs to be at least 25. Well, let's just do 35 again. That seemed to work well for us last time. These are a little pricier, but maybe we'll get lucky and it'll already exist again. Which one do we use here? The Worth electron, yeah. No, it doesn't. Okay. I'm just going to work my way up the list then. Like I said earlier too, this doesn't matter a whole lot. We can always pick a different one. It just matters. I just don't want to have to make the footprint. This works. That symbol is sketchy because it doesn't have the positive marking. Yeah, no, we're going to have to find something else. Eventually I'll find one. These start to get expensive kind of fast too. Could we just use the one we already did, but change like the name of it or something? Maybe. So that's always an option. This is actually going to be a really expensive board. We may not end up using all channels. Just because we're not going to be able to afford to populate them all. I am running out of options here. Well, let me place this one that had the sketchy footprint and see what it looks like. Does that tell me which side it is? No, it just tells you the part. That's really annoying that they would do that. Although I guess the footprint didn't really look like it had a marking either. We can add our own marking after the fact. And I'll see it too when I'm putting it on there that it's gonna need something. Ugh, sorry. All right, and then we will wire this up real quick. And I believe this connects between ground. Let me find this real quick. Yeah, it connects to ground, okay. I'm probably going to call it here as well. I'm just getting really tired. So that's a good start. Obviously, there's still a pin that's not connected. That's this inverter pin. It needs to connect to a voltage divider that will tell it, you know, exactly what voltage to be at. So that will be upcoming. Yeah, we'll figure out exactly how we want to do that. But yeah, so good times. I think what I'll do real quick then, since we have a little bit of extra time, is I'm going to go ahead and make a PCB document. Because I just want to see how big all these components are. All right, update PCB document, Validate changes, all of them. Execute changes. I love these giant, like our big regulators right here. And then there's just massive capacitor. Like, that's just awesome. Our components for dealing with the AC is pretty epic. This is going to be a pretty big circuit board. We'll just cram everything in there as best we can, but I bet the 3D view looks even cooler. Oh, they're red. Hold on. Is that because they're too close to each other? Or why? Interesting, it doesn't tell me. It's just coloring them red for some reason. Height constraint. I didn't know there was such a thing. Apparently all of those items are too tall. So they're violating some sort of height constraint. Here's our little plug though. That looks fun. Looks like it's covered up pretty good, so we're definitely going to need that. Well, awesome. Well, thank you all for joining me tonight. It's been fun, and I'll be back on Thursday. We'll do put together this voltage divider with some sort of adjustable chip so that we can make whatever voltage we want. And then I think that and that capacitor, and that's it for this part of the circuit. Hopefully that won't take too long, so then next time we can also look into getting fuses, relays, and the mechanical switches. So yeah. Should be fun. All right. I will see you all later. Have a good night.